Hi, I'm Andrew Armstrong. Welcome to the Back Office Teardown Lab. It turns out to me that this is an electronics project, but I wasn't aware of that till I opened this mystery envelope. This envelope turned up at my house, directly to my house address, unendorsed. Look, I might be able to peel that stamp off, create and commit some mail fraud there. But when I opened it, this is what was inside. Just some wires and no documentation, so it may well be as part of a sort of conversation I had with somebody. Maybe I gave them my home address. I really can't remember. And if it, you know who you are, please get in contact with me and just remind me, because I am quite forgetful and I have about 1 billion people every day talking to me about stuff, so I do forget things and I'm really sorry about that. But I'm really grateful to get something. I'm just going to unwind it, unravel it. I did a little bit of digging on this because I had a quick play. So you've got a buzzer here, and you may or may not be able to read the writing of it, but I'll turn it around for you. There you go. It's a KST G951AP rather, and it does have a polarity. There's a plus and minus on that, which is interesting. And then on the other end of those two wires, you'll see there's a transistor, and the transistor is a BC547. Don't worry, I'll make some notes so you can see what's going on here. And there's a resistor there on the base. The collector's connected to the buzzer, and the emitter, the emitter is just sort of hanging there, just connected to nothing, because it's not a complete circuit. So I did a bit of thinking about this, so I've sort of listed out all the parts. So there's your transistor. It's sort of a standard sort of signal transistor-y type thing, nothing too exciting. You can get a datasheet online if you want. And there's the whole transistor-y picture. It's an NPN, as you can see. And then looking at the buzzer itself, it's this KST G951AP. Whew, mouthful. And they class that as a buzzer. And I thought that, oh, buzzer. They say it's a 2.73 kilohertz resonant frequency at 5 volts. I thought, oh, that's interesting. So I put 5 volts on this directly just to see, because I kind of expected to go, you know, those buzzers, like a, but yeah, it doesn't do anything. I think it's classed as a buzzer, but it's just like a speaker. You know, the sort of speaker you get in a PC. So it doesn't. It's speaker in that it's not really a wide range of sounds it can make. It's used for making blips and blops, whereas this is more of a speakery speaker. Looks like a traditional speaker. That's fine. But it has a polarity, so that kind of threw me, because I thought you had to wire it the right way, but I don't really think there's anything in it that really requires it to have a polarity. And this is the circuit. So just to explain how it works then, so you'll have something driving your circuit in this and I'm guessing it could be a microphone, it could be a low level sort of analog source, or it could even be a digital source like a microcontroller. So you know, it could either be a microphone doing audio waveforms, but possibly you'd have, because it's AC at that point, you'd probably have a capacitor before you come in here, or it could be just a digital one running out of your microcontroller, just firing it straight in. I don't really think you'll bother with a capacitor on that one. And what happens here, basically, when this gets somewhere probably between 0.6 to 0.8 volts, definitely 0.8 volts, it'll be kind of on. The transistor's going to start letting current flow through it to the ground or earth, however you want to describe it, and that means there'll be some current going through the buzzer. So if there's something going here, this will start doing a there, but at a much higher current, and sound will start being produced. Now, I don't happen... Oh! Jump cut. I'm back, and I was just about to say I don't have any real good way of testing this circuit right now, but unfortunately for you and your ears, I do. Because if you recall a while back, in a Teardown Lab video, I actually built this circuit, which is a signal generator. So you can look on the edge, it's got a sort of square wave, a sawtooth wave, and the sine wave output at 12 volts, and you can fiddle around with various parameters of those sounds, or I say sounds, waves, that we translate to sound in this case. And I'm going to wire this up to this circuit, and we'll have a little listen. So, I don't know if you can hear that. I've got this hooked up to the circuit, the output's all hooked in. I'm running the circuit at 5 volts, although it can take 12 volts, so I don't want to blow up the speaker. And there you go. Not particularly loud, but very annoying. So I've just disconnected the buzzer that came with it, and I've got an actual little speaker here. So I'm going to hook the speaker up normally, just directly. I've not changed any of the settings since this was last buzzing away, so you can hear it. Yeah, you can't hear that at all. So we'll just see if we can hear something when we actually put it on the unit the same way that the buzzer was connected to it. I'm just doing it by hand. It's a bit dodgy, but yeah, there you go. Wow. So you can hear that, hopefully. But then if I put it again onto the thing directly, either onto ground, nothing, onto a live, nothing, but onto the transistor. So that's a neat little circuit. So if you need something to make a little buzz, and it's not going to be massively loud, it's not like a crazy powerful, you know, class D amplifier or whatever, but you just need, you know, you need it to make noise, and you know it's working, then definitely get onto this. I mean, this transistor, and let me write that down again one more time, BC547. And I bet if you look at this, this will be like, you know, any transistor you pull out of virtually anything will do. I'm sure will do for this. And that just works great, just a lovely little indicator. So if you're doing anything with microelectronics and you want something to, you know, you got a little circuit board and you want to make it do a little beep or make a buzz, then definitely. I think this is a very low investment circuit for you. Hope this has been useful to you. Thanks again for sending this in. I really appreciate it. Please leave comments down below. Click like and subscribe if you're that way inclined. And as ever, thank you for watching.